Okay. So Sydney, if you're talking about the review from the book, you're going to need to ask some specific questions. Okay? 'Cause I don't know. I'm not doing the whole review, so please ask specific numbers from that review so that everybody knows and I know what your questions are. Okay, so 16, 17. Again, you're not being very specific because there's lots of questions within there, within those. So number 16 has 5 questions and number 17 has 2 questions. All right, so let me talk about the concept of number 16. They're asking you to find the values of the following trig functions correct to 4 digits. And so you know that I keep saying you take trig functions of an angle and you get a ratio. So for part A, okay, so this is page 473, number 16. All right, so part A says they want us to find the secant of 13.7 degrees. All right, I think I'm going to write this saying down. Let me go to the next page to write it. You take trig functions. You guys want to see my puppies? One of them. This is my daughter Lauren and my puppy Bear.
He's cute, bedazzled.
He's a boy, but he has a bedazzled collar thanks to Lauren. All right, bring Snickers up if you want. Okay, you take trig functions of angles and you get a ratio. So that is actually more important than you guys realize because sometimes you guys do things and it's like, they don't even realize they're not taking a trig function of an angle. Anyway, you take trig functions of angles and you get a ratio. Okay, I'll probably use that a few times tonight. Then the other thing I want to say is when you're talking about reciprocal functions, the reciprocal is of the ratio, not of the angle. So I'm going to say you never take the reciprocal of an angle. But you do of ratios, okay? But you never take the reciprocal of an angle. All right, so those are just 2 really good phrases for you guys to just say over and over and over again to yourself. So when you get stuck on something and you're like, I don't know what they're asking for, let me go back to the previous page. Number 16 rather, A says find the secant of 13.7 degrees. If you don't know what they're asking for, look at what we have. We have secant, that's a trig function. We have 13.7 degrees, that's an angle. So you take trig functions of angles and you get a ratio. All right, now I don't have a secant button in my calculator, so I'm going to say if I knew what the cosine was of the same angle, then I would want the reciprocal of that. Well, here's how you write the reciprocal of in math, 1 over. That means the reciprocal of. So I'm going to say 1 over cosine of 13.7 degrees. Now I'm going to put in parentheses here what I think some people are going to do. They're going to say secant and cosine are reciprocal, so they'll think it's cosine, and then they'll go 1 over 13.7 degrees. Isn't this person in parentheses taking the reciprocal of an angle? And so that's why I said that phrase, you never take the reciprocal of an angle. So that's wrong. But do you see the similarities between the correct step, this is correct, and then this wrong one that I crossed out? They both have a cosine, they both have a 1 over, but completely different things. Okay, the first one, I'm taking the reciprocal of the cosine ratio. The second one that I crossed out, that's taking the reciprocal of an angle, and you never do that. Okay, now you have to tell your calculator what mode to be in. Okay, so hitting the DRG button allows you to switch back and forth from radians to degrees. And so this angle that they gave me, 13.7, is in degrees, so I'm in degree mode. All right, so 1 divided by cosine 13.7, and then they asked me to round to 4 decimal places. And so this is approximately 1.0293. And that is a ratio, and ratios don't have any units. Okay. Okay, I was just reading Kay's question. Yeah, feel free to ask any questions from the quiz or the review, anything. All right, let me finish though with some examples from that number 16. All right, so that was secant. Let's see. I guess I'll do one with degrees and minutes. B says tangent of 143 degrees, and then it says 10 minutes. Well, I'm going to write 143 plus 10 over 60. Do you agree that is how we converted from degrees and minutes into decimal degrees? Okay, so again, I need to be in degree mode. Now this time I do have a tangent button, so I just hit tangent of 143 plus 10 divided by 60, and then I can hit enter. You don't even have to close the parentheses, and I get approximately negative 0.7490. So I'm rounding off to 4 decimal places. And if you're wondering at all, let's see, is that negative 0.7490? Could that be an angle in radians? Well, listen to my little sentence I'm going to say. Starting with tangent, you take trig functions of angles and you get a ratio. So that negative 0.7490, that is a ratio, and there are no units on ratios. Okay. All right. Then we have our little page that has our sayings. You take trig functions of angles, you get a ratio, and you never take the reciprocal of an angle. Okay. I'm going to do part C on number 16, and then we'll move on to 17. 16C. So this says cosecant of, so I can see that I'm going to have to do a little reciprocal work, okay, because I don't have a cosecant button. And then what makes this problem tricky is the angle is negative and there's degrees and minutes. So if I write plus 20 over 60 and write it exactly like this in my calculator, I'm going to get this wrong, because the way this is written, the way I have it right now, I'm making the 217 degrees be negative, but the plus 20 over 60, that part's positive. That is not correct. The whole thing is negative. So when I enter this in my calculator, I'm going to have to put parentheses around the numerical part and have the negative sign outside of it so that it applies to all of it. Okay, but again, I don't have a cosecant button, and I know that I do not want to take the reciprocal of an angle, but I do want to take the reciprocal of the sine of the same angle. So I'm going to go, when I enter this, I'll go 1 divided by sine. It'll automatically put this left parenthesis. I'll put the minus sign, and then I have to put another left parenthesis and say 217 plus 20 over 60. And then you could close the parentheses, but I'll actually just be hitting an equal sign right here. Okay, so again, I need to be in degree mode. Notice I check that every single time. So 1 divided by sine, that's the reciprocal of cosecant, and then of the same angle. So I go negative sign, and then a left parenthesis again, 217 plus 20 over 60. And then I hit enter, and I get approximately 1.6489, and that is a ratio. Okay, and so there are no units. Okay, let's move on to number 17. So 17, it says find the value or values of the following trig functions. Give answers correct to 4 significant digits. So notice the difference. The first previous 3 examples I did, it said, oh, you know what? I think I did read it out loud, but I was thinking 4 decimal places. It says 4 digits. So let me go back and double check those answers. So for part A, that is not 4 digits. That's 4 decimal places. They wanted 4 digits. So I should have stopped at 1.029 and not put that 3. Okay. For the second one, part B, I'm going to cross out the 0. So I'm sorry, they said 4 digits. Let me go back and undo that. That 0 should be there for that one. 4 digits. It happens to also be 4 decimal places. Okay, but they said 4 significant digits. Or correct to 4 digits. All right, and then on part C, yep, I'm going to get rid of that. Actually, I'm going to change this to 1.649 should be my answer. So there's 4 digits. Okay, so that's the difference between saying 4 decimal places compared to 4 digits. They did not want 4 decimal places. They wanted 4 digits. Okay, so I have not started writing anything yet for number 17. Let's go to the next page. All right, number 17A. So they give me cosine of 1.43 1.4341. I bet I can convince some of you that that 1.4341 is a ratio because it kind of does look like a ratio, doesn't it? But if you say my little sentence, you'll go, wait a second. No, you're taking the cosine of that. And you know that you take cosine or trig functions of angles. So this 1.4341 has to be an angle, but it doesn't say degrees. That means it is radians. Okay, I want to take the cosine of 1.4341 radians. Now I have a cosine button, so all I have to do in my calculator is change the mode by hitting this DRG button and then cursor over to the radian and hit enter. And you'll see on your screen in the lower right-hand corner that it now says RAD for radians. Okay, so I simply enter cosine of 1.4341 and hit enter. And these directions also said 4 significant digits. In this case, it happens to also be 4 decimal places, 0.1363. And that is a ratio because you take trig functions of angles and you get a ratio. Okay, 17b says tangent of, I'm kind of surprised they didn't do any reciprocal functions, 2.3969. Okay, I've got a tangent button. I'm in radian mode, so I just enter tangent of 2.3969. And then enter, and I get approximately negative 0.9217. And that is a ratio. Okay, all right, I'm just going to make one up. There is no part C, but let's pretend they had said, let's find the secant of 2.1345. Okay, so that 2.1345 is an angle because I'm taking a trig function of it. I personally think you should write this out, not just kind of try to guess in your calculator. Since you never take the reciprocal of an angle, I'm not going to go 1 over 2.1345, but I am going to say 1 over the cosine of the same angle. Okay, and since that angle is in radians, I have to be in radian mode. And so if this was our question, I would go 1 divided by cosine of 2.1345. And then I hit enter, and I would get approximately negative 1.872. And I'm just going to go to 4 digits. And that would be my ratio. Okay? All right. I just wanted to show you one with a reciprocal function. You never take the reciprocal of an angle. Okay. Okay, so Audrey is asking, when do we know to use radian mode versus degree mode? So let me go back to my previous examples. On number 16, they gave us the angles. Okay, so look at 16a, Audrey. It was secant of 13.7 degrees. Well, that angle is in degrees, but you have to tell your calculator that. So this one would be in degree mode. And I'll put a D for degrees. Okay, part B, that's 143 plus 10 over 60, but that's in degrees. So you have to tell your calculator. My angle is in degrees. Okay, and then for part C, that angle was also in degrees. So all of 16 was in degrees. Okay, then I came across number 17, and now look at my angle. I'm taking a trig function, cosine of this 1.4341. So that's an angle in radians. So this one, 17a, I had to be in radian mode. Okay, and 17b also radian mode. And then I made up this third one, and that's also in radian mode. Okay, so you need to try to be careful to keep looking at your angle or look at the directions and see, probably do some examples where they're asking you to solve for the angle. Here I was solving for ratios. And if they want the angle in degrees, then you have to be in degree mode. If they want the angle in radians, then you have to be in radian mode. Okay, so be careful about that. Okay, let's see. Elise 453. All right, this is not from the review. Page 453 is 7.8, section 7.8, 21 and 29. Okay, so 21, right, this is page 453, number 21. Okay, let's see. They give us an equation, y equals 2 sine of the quantity 2x minus pi over 2. Okay, and we didn't add anything to this one. All right, so your first step must be to factor out the b. So this 2 right here, your book always puts it inside the parentheses. We want it outside of the parentheses. So I'm going to write x minus, and then some of you are struggling with this next number that goes right here. I strongly advise that you put your fraction sign, put a pi in the numerator, and then stop and look. I want that 2 that's outside of the parentheses to cancel with something in the denominator so that I'll end up with a 2 in the denominator. So if I put a 4 here, do you see how this 2 outside the parentheses that I factored out would cancel with that 4 and would give me negative pi over 2. Okay, I'm going to do this a couple of different ways. If you label them in alphabetical order, A, B, C, D, then you get 2 for A, 2 for B, positive pi over 4 for C, which means I'm going to shift to the right, and there is no D, so I'm just going to cross that out. Okay, now if you guys want to write them in BCAD order, that is the order that I'm going to take care of these in, BCAD, then you certainly can. Okay, so B I know changes the period. So the basic period for sine is 2 pi, but my B is 2, so I divide by 2, and I get a period of pi. Next, I'm going to find my increment length. Whatever I got for the period, you take that and divide by 4. And so there's the increment length. Now my shift to the right is also pi over 4, so that makes it kind of easy. All right, so I'm going to go like this and say that's pi over 4, my new starting place. So I'm going to cross the little X through the y-axis so I don't accidentally start right there. My new start is at pi over 4. Okay, and since my increment lengths are pi over 4 units or radians, then I'm going to count in increments of 1 pi over 4. So the first one's 1 pi over 4. The second one is 2 pi over 4. But look what I just wrote. I simplified it. The next one's 3 pi over 4. The next is 4 pi over 4, but I'm going to write pi. And the last one is 5 pi over 4. You absolutely should take the last coordinate, so in this case 5 pi over 4, subtract the first one, 1 pi over 4. That gives me 4 pi over 4, which equals pi, and that's exactly what the period was pi. Okay, I'm going to graph a sine curve right now with an amplitude of 2. So on the y-axis, I'm going to put 2 tick marks, and you guys, those of you who are in my class, you need to label that positive 2 and negative 2. Okay, any critical values, I should be able to just look over at your y-axis and go, oh, I know exactly how high or low this is. Okay, so this is a sine curve. Remember, we're not starting at the y-axis. We do it in a different color. I'm starting at pi over 4, and I get a midpoint, next a high point, then a midpoint, next a low point, and finally a midpoint. Okay, so since there is no D, I'm going to go ahead and make this solid. I know it's not quite smooth. I'm drawing this thing, but try to do a nice smooth curve. Okay, now I would like to know if this is correct or not, and many of you are not checking your work. So if I take this point, I prefer to pick a high point. So I'm going to pick the highest point on this one cycle of my sine graph, and it's the point pi over 2 for x, comma, 2 for y. All right, so we're going to plug in pi over 2 and bring it to our original equation, not the second one, the factored form. Put it back into the original equation. All right, so pi over 2 times 2. Excuse me, you might be thinking that the 2's are going to cancel, and they could, but I'm going to leave it there. 2 pi over 2 minus pi over 2. See, now I have a common denominator. And so when I subtract those, I get positive 1 pi over 2. Okay, so that's my angle, and now I want to take the sine of pi over 2. So I need to know that pi over 2 is 90 degrees. If I go in standard position and go to 90 degrees, I'm right here at the positive y-axis, and I want the sine of that. So that is 1 over 1. I get a ratio of 1. And then, lastly, I want to multiply that 1 times 2, and I get 2. And let's go back to our point over here. That is exactly what we wanted, was pi over 2, comma, 2. Okay, so probably your graph is correct. Okay, let's see. Elise is also asking for number 29, and we added something at the end, plus 1. Okay, so number 29, it says y equals 2 sine of 1/2 x plus pi over 4, and then we're going to add a plus 1. Okay, so step 1 is factor out that 1/2. I'm left with x plus put my pi right there, and I start to think to myself with a 2 in the denominator and another 2 in the denominator, wouldn't that give me a 4 in the denominator? Okay, so that's good. All right, this time, since I just did one with A, B, C, D, and I put them in alphabetical order, this time let me write B, whoops, B, CAD, and then list those values. Okay, so B is 1/2, C is negative pi over 2, which means to the left, A is 2, and D is 1, since we're going to shift it up. Okay, so going in that order, BCAD, I know that B changes the period. The basic period for sine is 2 pi. I'm going to divide by 1/2, which is the same as multiplying by its reciprocal 2, and I get a period of 4 pi. However, I want to know what my increment length is. I'm going to take that period and divide it into 4 equal parts. And so each of my increment lengths will be pi units. Okay, I'm going to compare that to my shift. My horizontal shift right now is negative pi over 2. So I'm going to rewrite this increment length and say it's 2 pi over 2. Okay, do you agree it still equals pi, but now I have a common denominator. Okay, let's get our graph started. So let's see, I am going to go to the left, not too much. Okay, so if I have increments of pi over 2, I'm going to make this the 1 increment, and it's to the left, so negative pi over 2. Okay, from there, I want to go to the right, because this is a sine curve. I'm not doing half of it to the right and half to the left like we do for for tangent. All right, since this is negative 1 pi over 2, and I want to go positive 2 pi over 2 to the right, from that tick mark that I have right now to the left of the origin, if I were to go right to the origin, wouldn't that be 1 pi over 2? And I want to get to 2 pi over 2, and that's going to be my next critical value. Okay, if you want to start doing the little tiny tick marks and the bigger ones, you certainly can. Or you can just kind of eyeball or maybe use your fingers and say that's about how far it is from the first tick mark to the second. And I'm going to then just duplicate it. So I would get one here and one here. Okay, and then each time I go from one to the next, going to the right, I'm going to add 2 pi over 2. So when I add 2 pi over 2 to that first one, I get positive pi over 2. When I add it to get the next one, I'm going to get 3 pi over 2. And then 5 pi over 2. Add another 2, I get 7 pi over 2. Okay. All right, I'm going to do my double check. 7 pi over 2 minus a negative pi over 2. That ends up being plus pi over 2. So that gives me 8 pi over 2, which is 4 pi. And look at that. That is exactly what the period is. Okay, I'm now ready to graph a sine graph. I didn't realize this was sine again. So I'm doing a sine with an amplitude of 2. So on my y-axis, I'm going to go 1, 2, and I'm actually going to write 3. You'll understand why in a minute. Okay, let's just leave it with the 2 there. And then on the negative y-axis, I'm going to do 2 tick marks and call it negative 2. Okay, when I start my graph, I know a sine graph starts in the middle, not at a high or a low point, but a midpoint. And so on my axis, I'm going to put first point. All right, so that's at 0. My next increment is not the y-axis, it is pi over 2. And I want that to also be right here, because between the negative pi over 2 to the positive pi over 2, I just realized that I put the wrong point. I wanted my grid is not coming off. There it is. Okay, I wanted a high point. I'm getting tired, I can tell. Okay, so I started with a low, then I went to a high, then a middle. I think I just said I started at a low. No, I started at a middle, then high, middle, now low, and back to the middle. All right, now this graph I'm going to make dashed, and I know some of my students have been asking, do we have to do that dashed curve? You certainly don't. I'm just kind of doing it in baby steps. And for somebody who maybe isn't understanding graphing, it makes it a nice intermediate step. Okay. I'm doing the BCAD order. Let me write that out. BCAD. B is the value of B is what allowed me to find the period and the increment length. Then when I did C, I started on my x-axis going to the left, pi over 2, and then using my increment length to get all the x-axis. Right now, the dashed red curve that I just did, that's graphing a sine curve with an A of 2. And now finally, I'm ready to do the D, and that's to move everything up 1. Okay, so the 3 points that are on the x-axis right now, they're going to go up to 1 in the y direction. Okay, and then the high point is at 2 right now. I'm going to label my y-axis and say it's moving up to 3. And then the -2, it's going to move up 1, and it'll be at -1. So I'm going to label my y-axis there also. Okay, I'm still making this in red, but I'm making it solid this time. Okay, and I would like it to be a nice, smooth curve. This isn't the greatest because it's kind of hard to with this, but it should look like a nice, beautiful sine curve. Okay, now, I want to make sure that I'm getting an A, so let's plug in a point. All right, this high point right here is the point pi over 2, comma 3, and let's see if that's what happens. Okay, so I take the pi over 2 and I'm plugging it right here instead of this x. Okay, so pi over 2 times 1/2 gives me pi over 4. And so pi over 4 plus another pi over 4 gives me 2 pi over 4, and that is pi over 2. That happens to be a special angle. It's at 90 degrees, and I want the sine of that. So sine of pi over 2, which is 90 degrees, gives me 1. 1 times 2 is 2, and then add 1 to it. And I do, get 3. And so I know I'm getting an A on this. Okay? All right, there you go, Elise. All right, Kay, we did a quiz today. Wanted to go over the backside, especially the finding the radians from in between 0 and 360. All right, so Kay, have you asked a specific question? No. All right, so let me get my quiz out and see what questions Kay is asking about. Okay, so on the back side, the first 3 questions, 11, 12, 13, those are all trig functions of angles. We just kind of went over that at the very beginning of tonight, so I'm not going to do that again. Okay, and then when you get to 14 and 15, now they're asking you to solve for an angle. Okay, and some people struggled with this. All right, so number 14, put a Q for quiz. Quiz number 14. The directions say, given the trig ratio and the quadrant, find theta first in A, radians, 0 to 2 pi, and then in B, degrees, 0 to 360 degrees. And then it says, round everything to the nearest tenth. Okay, so 14a, it says cotangent of theta equals 1.2482, and our angle is supposed to be in quadrant 1. Okay, so you take trig functions of angles. Cotangent is a trig function, happens to be one of the reciprocal functions, but you take trig functions of angles and you get a ratio. That means this 1.2482 is a ratio. And, excuse me, so I'm going to do some writing. If tangent, since I don't have a cotangent button, if cotangent of theta equals that ratio, then tangent of the same angle equals 1 over that ratio. Okay, and they're still telling us that they want it in quadrant 1. Okay, so in order to get theta all alone, don't I have to take the inverse tangent of both sides? I'm going to put big parentheses around here and say I'm taking the inverse tangent of both sides. That inverse tangent is what is going to take the tangent away, and I'm going to get theta all alone. So theta equals inverse tangent of 1 divided by 1.2482. And there's my work. Okay, so now the directions, get in the right order. For part A, says they want it in radians. So I'm going to change my calculator to radian mode, double check it, and I'm going to enter inverse tangent of 1 divided by 1.2482. And then enter, and I get that theta is approximately 0.6754. Okay, and I'm not going to say what the units are, but I was in radian mode and they told me to do it in radians, so this is radians. I'm actually going to write it out. Okay, so there's 4 significant digits. What did they say? Actually, they said to round to the nearest tenth. Okay, I didn't love that on this part. They actually asked for the nearest tenth, so this would be approximately 0.7. Very inaccurate, but that's what they asked for. So 0.7 of a radian. Okay, for part B, they want you to do the same thing, just do it in degrees. Okay, so you started off with cotangent of theta equals 1.2482, and this time they say, give us the answer in quadrant 1. That's supposed to be a Q. Okay, so I don't have a cotangent button. I certainly don't have an inverse cotangent button, so I'm going to write something down. Tangent of the same angle equals 1 over this. Okay, do not mistake this for taking the reciprocal of an angle, because you never take the reciprocal of an angle. All right, now to get theta all alone, I'm going to take the inverse tangent of both sides. On the left side, that gets rid of the tangent, and you end up with your x. On the right side, I want the inverse tangent of this ratio. Okay, so let's see. Now, what am I doing? I am finding my answer in degrees. So I'm going to change the calculator to degree mode. Okay, I'm going to go inverse tangent of 1 divided by 1.2482. And this answer is going to be in radians. Excuse me, degrees. Now we're doing degrees. So theta is approximately 38.7 degrees. And they said nearest tenth. Did I change that 1 to the nearest tenth on the previous? Yeah, 0.7. Okay, and I don't love that. It really should have been 4 decimal places. But anyway, so here's my angle. Do you agree that in standard position, 38.7 degrees terminates in the first quadrant? That's exactly what they asked for, so we're done. Okay, all right. Let's see. Number 15. So it says cosine of theta equals negative 0.8616. That's my ratio, and they would like the angle to be in quadrant 3. Okay, so to get rid of the cosine and end up with just theta on the left-hand side, I'm going to take the inverse cosine of that ratio. Okay, let's see, what do they want first? They want radians first, so I'm going to change the mode to radian mode, and then I'm going to take inverse cosine of negative 0.8616. And then I hit enter, and theta is approximately 2.60. Was this? This is the one that they want to the nearest tenth. So I'm actually going to lose that 0. 2.6 is my final answer. All right, that's number 15. A, 15B. Of course, is the same problem, but they want me to do it in degrees now. So I just want to show you a little shortcut. I have this in my calculator for radians. I'm just going to go to my DRG button, change it to degrees, and then I hit enter again, and it brings me back to what I just entered in my calculator. And so I can hit enter one more time, and it will now do it in degrees. So theta is approximately 149.5 degrees. Okay, that's the only angle they asked for in this case. Oh, but we're not in the right quadrant, so we're not done. Okay, so this is where I feel like some of you just like try to guess what you're supposed to do. So they asked for quadrant 3. 149.5 is not in quadrant 3, so you need to draw a picture. Starting in standard position, all the way around to pi would have been 180 degrees, but they were doing it in degrees. We're at 149.5, so that is going to be in the second quadrant. Okay, and if this is 149.5 degrees, then let's draw the same thing in the third quadrant where they asked for it. And if from here to here is negative 149.5, how do I get the coterminal angle that is positive? So let me show you where it starts, here at 0, 0, or 0 degrees rather, and I want to come all the way around there. So isn't it actually my negative 149.5 plus 360 degrees to get a coterminal answer? Okay, so here you're probably thinking, what mode should I be in? It doesn't matter, I'm just adding numbers. So I'm going to go negative 149.5 plus 360 degrees. And when I do that, I get 210.5. Okay, so I see some questions. Okay, can you review on number 29 how you check a point? Because I'm so confused. Okay, let's go back to number 29. Here we go. Okay, I'm glad you're asking, Elise. Okay, so you can actually plug in any of the 5 critical points, right? Because we know the X and we know the Y, so we could check any of them. I recommend you try to get yourself in the habit of plugging in a point every time you graph, and I would suggest that you plug in a high point. Okay, so on this graph, my sine curve for number 29, do you see that that high point has an X value of pi over 2, and then comma, a Y value of 3. Okay, so this is the point right here that I think is supposed to be on my graph, but I want to see if it satisfies the original equation. All right, so I've already done this work. Look up here where I've plugged in the pi over 2 instead of x. Okay, so then you kind of are working your way out, okay? Mostly backwards, but working your way from here and then working your way out of the equation. So the first thing I want to do to that pi over 2 is multiply by 1/2. So 1/2 times pi over 2 is pi over 4. Then I want to add the other pi over 4, the second term over here. So I have pi over 4 right now, plus another pi over 4. That adds up to 2 pi over 4. And since that can be simplified, 2 pi over 4 simplifies to pi over 2, and that is a special angle. Circle it, I have it written right here. So pi over 2 absolutely is a special angle. It's a quadrantal angle up at 90 degrees, and so the sine of 90 degrees is 1. And then 1 times the 2 that's right here, I'm underlining it in red. So 1 times 2 is 2. And then come all the way to the outside of everything. If I have 2 plus 1, I end up with 3. And then I look at my point and I say, yes, that is perfect. That's exactly what I was wanting. Okay. All right. I hope that was helpful. Okay, can I do number 9 on the test? Let's take a look at that. I presume you mean on the quiz. Okay, quiz number 9. Okay, number 9 says they want us to find the exact value of the expression of the following expressions showing work when necessary. All right, so cosine of 11 pi over 6 minus 2 times the sine of 2 pi over 3. Okay, if you need to draw a picture for each of those angles, then you should draw a picture for each of those angles. Starting in standard position, I'm going in the positive direction. Okay, but then I keep on going and I go, wow, that's almost all the way around. All the way around would have been 12 pi over 6. So that means I want to go 1 increment of pi over 6 less than that. So I'm going to draw like this. perpendicular to the x-axis. There's my reference triangle. And if this hypotenuse is 1, let's switch colors. If my hypotenuse is 1, what is the short leg? It would be 1/2. And the long leg, rad 3 over 2. Okay, and now I'm going to think to myself, for this 11 pi over 6, I want the cosine. Cosine is x over r, and so isn't that rad 3 over 2? So notice, even though I drew my picture and everything, I did it a little bit off to the side. Right underneath cosine of 11 pi over 6, I'm writing the value of it. Okay, then I'm going to copy the minus sign. I'm going to copy the 2, and now I'm going to take the sine of 2 pi over 3. Now, I like to take anything that's pi over 3 and change it to over 6. So wouldn't this be equivalent to 4 pi over 6? Okay, and so I'm going to draw a picture of it. We'll figure out what it is, and then I'll put it in the blank right there. All right, so 4 pi over 6. I know pi over 6 is 30 degrees, so I'm going to start in standard position, and then I'm going to go kind of figuring out where the 4 pi over 6 is. So here's 1, 2, 3, 4 pi over 6. Okay, so you should see how that's forcing me to make an accurate looking 30, 60, 90. I draw perpendicular to the x-axis. If this is 1, can you tell me what this is? It's negative 1/2. And then the long leg, rad 3 over 2. Okay, so I wanted sine of 2 pi over 3. And so sine is y over r, and so that's the square root of 3 over 2. Now, my initial instinct is to cancel the 2's. Okay, you don't want to do that because these two terms have a common denominator already. Okay, so I have 1 of these rad 2, excuse me, 1 of these rad 3 over 2's, and then I have minus 2 of these rad 3 over 2's. So isn't that negative 1 of these rad 3 over 2's? And that's the final answer. Okay. Whew, I'm getting tired. Okay, let's see what else we've got. That was 9 for Brian. Okay, Ed is asking 2.6. Oh, did I mess up? 2.6 is not in quadrant 3. All right, let me go back. I feel like I was doing that problem half asleep. Okay, this one in degrees, we did change it to quadrant 3. Where's my 2.6? There we go. 15A. All right, let me go back. Thanks, Ed, for catching that. Okay, yes, 15A was the one that they wanted in quadrant 3. So just like I did with the 149.5, let me go to the next page. I drew a picture of it. Since I have room here, let me draw my picture here also. So for 15A, 2.6 is in the second quadrant, just like my 149.5 is. Okay, and the way I know that is because if I start in standard position, this is 0 radians, all the way around to the negative x-axis is exactly pi radians, but I know the number pi is approximately 3.14, and I'm going to round it off even more and say it's about 3, just so that I know what quadrant my angles lie in. So if that's 3, then up here would be 1.5 approximately, and down here, 3/4 of the way around would be approximately 4.5. By the way, that stands for 4.5 radians. And then all the way around would be close to 6. Okay, now it's not exactly 6, it's closer to 6.28. Okay, but it keeps on going, keeps on going. All right, so Ed is absolutely right that 2.6 is here in the second quadrant. So I'm just going to kind of eyeball a angle. That's my terminal side right there. And I'm going to draw the same angle here in the third quadrant, which is where they told me it was supposed to be. I know those don't quite look the same, but just pretend it is. And then starting in standard position, if this is positive 2.6, isn't this negative 2.6? Okay, but then the angle that I want to know is the positive angle in standard position. So starting right here, I want to know all the way to here what that is. Well, if I just add one complete revolution, I'll get the positive coterminal angle. So I'm going to take that negative 2.6, and actually I would go back in my calculator and get the more accurate value. I kind of need to do that. Where is this? All right, it's in radian mode, inverse cosine of negative 0.8616. All right, there's my 2.6092097, etc. Okay, I'm going to say I want 2 pi and then plus that negative 2.6, or I can say negative 2.6 and then plus 2 pi. Well, it's not negative in my calculator. Okay, so you can either multiply it by -1 to make it negative and then say plus 2 pi. And when I do that, I'm going to get 3.6740. If they ask for 4 decimal places, they actually only asked for 1 decimal place, or nearest tenth rather. So 3.7 is my final answer. Okay, and this is back to number 15A. Okay, so this is not the final answer. 3.7 is, and that's radians. That's an angle in radians. Okay, thank you very much, Ed. Okay, Lisa, for 15A, why didn't you put 1 as the numerator? Okay, 15A, because this is cosine. See, that's one of the basic functions. I have a cosine button in my calculator, and I also have inverse cosine in my calculator. Now for 14, let me go back. I'm not positive if that's number 14. Let me see. Cotangent of 1. Yep, this is number 14. See, cotangent is a reciprocal function. I have tangent in my calculator, but I don't have cotangent. That's why I did the 1 over on 14. And then when I got to 15, because that's cosine and I have that button in my calculator, I did not do 1 over. Okay, hope that helps. All right, Sydney, can we do 39 from the book review? Sure. Okay. Page number. We have about 10 minutes. I'm sorry if my puppies bark loudly. All right, let's see, 39. It's on the next page. Okay, so anybody in my class, we're going to talk about this tomorrow, okay? I was behind by a day. Okay, I'll do it for everyone else and for you guys, okay? But we totally will talk about this tomorrow. Okay, so on page 474, number 39, they give you a graph and they're asking us to write the equation of that graph in this form. Y equals cosine of, and then they put in parentheses the bx plus c. Okay, so you know that normally they give us the equation in this form, and the first thing we do is factor out the b. Okay, so we'll talk about that b and the c in a second. Okay, here's the graph that they gave us. I'm going to do it in red. Well, let me start by doing the tick marks in black. Okay, so they have tick mark here, and it says negative pi over 4. Another tick mark, and it says negative pi over 2. Then I've got on this side positive pi over 4, pi over 2. And the next one is 3 pi over 4. All right, this is the part I'm going to do in red. All right, so we have a high point at 1/2 here. Then we have a midpoint at the negative pi over 4. Then we have a low point right on my y-axis here at negative 1/2. And it goes back to mid and then to high. Now, they have another point here at 3 pi over 4. I'm actually going to cross this out. Do you agree? Since they're asking for cosine in the directions, they ask for cosine. When I go to draw connect the 5 points that I have plotted right now, do you agree this is one complete cycle of my cosine graph? And that's exactly what I want to do, is only focus on one complete cycle. Nothing to the left of that, nothing to the right of that, just that one complete period. Okay, so I'm going to write A, B, C, and D, and let's talk about all 4 of those. Okay, B is the hardest of the 4 to calculate. You actually have to calculate it. The others, you should be able to just look at your graph and know what A and C and D are just by looking, but you have to know what you're doing. Okay, so A is The absolute value of A is the amplitude of my graph. That means the midline of my graph, which is right here on the x-axis. A stands for what is the distance between, different color, green, what is the distance from that midline to the high point, and what is that distance from the midline to the low point? Well, in this case, it's 1/2, so that's my A. Okay, C means how far did it shift left or right. Normally, my cosine graph starts at the y-axis. This time it started at -pi/2, so that's my C. And then D is how much it got shifted up or down. Well, the midline starts at the x-axis, and then if it had gotten shifted up or down, then I would have a D. In this case, there is no D. Okay, so now let's talk about how to calculate B. You guys know that B changes the period, so normally we write P equals 2 pi for the basic period of cosine divided by B, and then we simplify that. Well, this time, because I have the graph, I know what the period is. If I take, look at what I'm circling in green, pi/2, the last coordinate of my cosine graph, and subtract, so let me write this down, pi/2 minus a negative pi/2. Well, the minus and negative ends up being plus. I get 2 pi/2, which is equal to pi. So instead of this p, I'm going to write pi. Okay, so you should be able to look at that equation, pi equals 2 pi over b, and tell me that b equals 2. But we'll go ahead and solve for it. So whenever you have an equation like this where the thing you're solving for is in the variable, if I multiply by b and then divide by pi, do you agree it's like I'm just switching those? So I get b equals 2 pi over pi, and that equals 2. And so my b is 2. And now I can write my equation. Okay, I'm going to go to pretty blue. Y equals, I want A, so that's 1/2, times cosine. I'm going to write it the way my B and C truly are from the graph. So B is 2, the quantity, x minus my C, so it becomes plus pi/2. And then after I close the parentheses, I'm not going to write anything else because there is no D. Now, because they asked for it in this form, and it won't be like that on the test. On the test, it'll be asking you for it in this form, because that's how we've been writing all of our equations once we factor out the B. Because they asked for it in this form, if you're looking at the answers in the back of the book, it's not going to match this blue boxed answer. I'm going to distribute the two to get the answer in the back of the book. So 1/2, get my 2, 1/2 cosine of, and then in the parentheses, I'm distributing my 2. So 2x plus pi when I distribute. And that's going to be the answer that they have in the back of the book. Okay. In the blue box, that's what we're going to ask you to do on the test. Okay. Let's see. All right. That was 39 for Sydney. That was my last question. Okay, if you guys have any other questions, please ask now. By the way, anybody who knows that I was saying if we didn't have a good turnout tonight, this could have been my last GVL. I'm pleased to see 15 of you. Thank you for showing up. All right, I'm waiting for any last questions. Please ask if you have any. Okay, Sarah is asking for page 465, number 3. 465, number 3. Okay. All right, the equation they give us is y equals 2 times the secant of 3x plus pi over 3. All right, so step 1 is factor out the b. So 2 secant, 3 the quantity, x plus. I think quite a few of you are struggling with this next step. Okay, I have x plus something. Put your pi and your fraction sign, and then just stop and look at what you've got. I want this 3 that's outside of the parentheses to get multiplied by pi over something to give me pi over 3. So doesn't that 3 have to cancel with the 9 in the denominator? Okay, so 3 cancels with the 9, and there you go. Let's see, I don't know how to pronounce your name. I'm sorry, Elise, I guess. I'm sorry, but no, tomorrow's Thursday and I don't stay after school on Thursdays. I will be there Friday to help with calculator stuff, but no, and I was there today after school. All right, so Monday, Wednesday, Friday after school, I am always in my classroom for extra help for an hour. Okay, back to this. Let's see. I've got an A of 2, a B of 3, a C of negative pi over 9. And so that means I'm going to shift to the left. I'm going to put a little arrow there. And then D, there is no D, so I don't have to worry about that. Okay, I personally prefer to write the A, B, C, and D in alphabetical order because that's the order that it comes in on my equation. All right, but I'm going to take care of this in B CAD order. So B changes the period. All right, so the basic period, by the way, I'm going to be graphing in green cosine before I get my secant. Okay, so the period for, let's go ahead and do this in green. Period for cosine is 2 pi, but we want to divide by 3 because that's my B. And that makes my increment length, let me show my work, 2 pi over 3. Instead of saying divided by 4, I'm going to say times 1/4. So 2 cancels with the 4, and I get pi over 6. Okay, I'm going to look, this is kind of a tricky graph. I'm going to look at my increment length of pi over 6 and compare it to this shift of negative pi over 9. I have to have a common denominator between those two numbers, pi over 6 and negative pi over 9. So I see 18 is a common denominator between the two. All right, let me write this in red so it stands out. C is going to be negative 2 pi over 18. That's my shift. And my increment length is going to be 3 pi over 18 so that it has a common denominator. Okay, here is my graph. I'm going to go black for the X and Y axis. We're shifting to the left. Okay, so let me go here and there is no D. Let me go like that. Okay, I'm going to make a tiny tick mark to represent pi over 18 to the left of the y-axis. So then my next one I'm going to make bold, big and bold, okay? And that is going to be, switch to red, negative 2 pi over 18, but I'm going to write the simplified answer, so negative pi over 9. Okay, back to black. Now I want my increment length to be 3 pi over 18. So each of those tiny tick marks is pi over 18. So from the big one at negative pi over 9, I'm going to go 1, 2, 3 little tick marks, okay? And that third one, now I'm going to make it big and bold, and we're going to label it, okay? So if I think of that negative pi over 9 as negative 2 pi over 18, and I add 3 pi over 18, then isn't this one going to be pi over 18? Okay, I'm going to do tiny tick marks again just to kind of emphasize to you the making it to scale. So 1, 2, and then big, 3. Okay, and if I take pi over 18 and add 3 pi over 18, I'll get 4 pi over 18, but that simplifies to 2 pi over 9, so I simplify it. My next tick mark, this time I'm not going to do the tiny baby ones. I'm just going to kind of eyeball that that's about the size of an increment, and another one that's about the size of an increment. And now I'm going to label them. So let's rethink the 2 pi over 9 and think of it as 4 pi over 18. When I add 4 plus 3, I get 7 pi over 18. And then I do it again, add 3 pi over 18. That gives me 10 pi over 18, but I'm going to simplify to 5 pi over 9. It's actually easier when they don't simplify. Okay, excuse me, I would like to check my x-axis and make sure it makes sense. If I take 5 pi over 9 and subtract negative pi over 9, that ends up being plus pi over 9, I get 6 pi over 9, and that simplifies to the period of 2 pi over 3 that I'm circling right there in red. Okay, 6 pi over 9 simplifies to 2 pi over 3, so this is looking good. Okay, I'm going to graph in green my cosine graph with an A of 2. So let me label on my y-axis 2 and negative 2. And so I know that cosine starts at a high point, next a midpoint, then a low point, a midpoint, and a high point. And I'm going to make this dashed. This is my cosine graph in a nice light green. Okay, now for secant, I want the reciprocal of all of these y values. Okay, so the zeros that I have on my x-axis, where can I go? Let's go blue. Where the pi over 18 has a 0 on the x-axis, that's going to turn into a vertical asymptote because the reciprocal of 0 is undefined. Okay, then the high points, regardless what the y value is, the high points right there and there, those remain critical values, and then my graph approaches the vertical asymptote, and here approaches the vertical asymptote. And then the lowest point right here at -2, that remains a critical value, and my graph is going to approach those two vertical asymptotes. So those three portions of blue graph, that is my secant graph. Okay, let me do one last check of a point, and then we're going to say goodnight. So I would check this very rightmost point. So it is the point 5 pi over 4, comma 2. So let's plug in 5 pi over 4 in the original equation, right up here. I'm circling it in blue. Don't do it in the one where you've already factored out because maybe you factored incorrectly. Okay, do it back to go back to the very original. Okay, so instead of this x, I'm plugging in 5 pi over 4. Nothing cancels, so I end up with 15 pi over. Oh, that's not a 4. Whew, I'm glad I saw that. Things were starting to not make sense there for a second. I was like, why is that over 4? That's a 5 pi over 9, not a 5 pi over 4. Okay, glad I got that. Okay, so 5 pi over 9, we're multiplying it by 3. That ends up giving me 5 pi over 3. But then I need to add pi over 3. That gives me 6 pi over 3, and that is 2 pi. Once I simplify all that mess right there after the secant, I have to get a special angle. And 2 pi is a special angle. It's a quadrantal angle. Okay, so I'm going to step away from this equation and just think about my unit circle. If I start in standard position and go around 2 pi, I end up back at the positive x-axis. I'm actually going to think about what's the cosine of that. It is x over r, so that equals 1. And then I'm going to take the reciprocal of 1, because this says secant. So the reciprocal is still 1. And then I multiply by 2, and I get 2. And I look at my point, and that is exactly what my y coordinate is. Yay, we're getting an A. Okay, I'm sure glad I caught that 9. Okay, I hope that was helpful, Sarah, and everybody whose questions I answered. And I hope you have a nice evening and good luck. If anybody needs extra help on calculator stuff, Monday after school, I will be in room 402 for extra help. Okay? All right, have a nice evening. Good night.